The way we interact with machines is that we have to adjust ourselves to them. If devices and machines were able to understand how people are feeling, they could adjust themselves. AI is everywhere around us now, with wearable devices, with smart objects, smart environments. My focus is on using AI and sensors to understand humans and analyze their behavior. We're trying to adjust ambient factors in accordance to people's preferences and basically use emotional feedback in order to further adjust the environment around people. If devices and machines were able to understand how people are feeling, they could adjust themselves to us. What we're trying to do is to get devices to be very personalized and customizable and adaptive to humans, as opposed to us adapting to machines and devices.
I try to think of how humans behave and then kind of apply that to robotics. My lab is called the Biomechanics Cross Robotics Lab because it's a blend of human biomechanics and robotics. I study how humans walk, how they get from place to place, and how they balance. And also at the same time, what can we put in our robotic devices to help people walk? The robotics is both to help humans and also both for exploration. You know, if we can send a robot that can walk through like an unstructured environment, it might be dangerous for humans. So I think if we do a good job of thinking about how it can impact the world and designing from a more equitable perspective, not only on the mechanical aspects of how it impacts how we walk, but our interactions. So I'm kind of excited to think about a future where humans and robots can interact in a very positive way, in a very seamless way as well.
Imagine that if we're able to collect all of this sensor data related to how a building or a bridge is performing, you could think about it in a way like our structures are trying to tell us how they feel. Infrastructure monitoring combines traditional use of sensors to try to understand how our structures are performing together with artificial intelligence, and we could use it to try to assess their structural condition. Can we make our structures smart in a way so that they're able to tell us when they're feeling unwell and retrofit or repair that structure before the damage gets worse? We can use that data to inform our future designs and hopefully design structures that are more resilient. There's a potential to use advancements in artificial intelligence and robotics. When we combine our knowledge together, suddenly we're able to tackle some pretty significant challenges.
Bio-inspired robotics gave us this idea to use nature as an inspiration to build machines. And then the natural next step is, well, what else is there out there? I'm interested in building robots that interact and are safe to work with. Bio-inspired robots use the same morphology or the same structure that you would find in biology. There are plenty of examples of soft-bodied organisms which can do some pretty amazing things, like snakes, which can climb trees and can go into places that you can't normally send machines or that we can't go. How would you physically build it? How do you power the system? Another interest of mine is to build swarm-style robots. You could send a swarm of several smaller robots, each with its own individual speciality. So you could have some robots meant to detect gas leaks and others meant to detect personnel in an area. So there's a lot of untapped opportunities in the field. And that really, I think, is going to be the future of robotics, is putting robots closer to us in our daily lives.
We want a computer to understand human languages. We want a computer to understand written language and speech and images. We are developing algorithms to try to understand gestures and also positions, activities of human beings. We can put all these kind of multimodal data all together, together with speech, language, and information from sensors to understand human knowledges and use these acquired tech capabilities to deal with many real-life applications. This is a very unique age, we can push forward to really build a system that can help to increase our productivity, build a better life for humans.
And went to Carleton University, where I studied space systems engineering, and then moved on to the University of Toronto, where I continued to study space engineering. My research was focused on developing new satellite technologies for debris mitigation. After my master's degree, I actually started working before coming to my PhD. So I got to build hundreds of space devices. I got to design them, test them, and a number of them are now in space, orbiting us 15 times a day. In my PhD, I'm hoping to contribute to the global effort of planetary exploration. And in particular, I want to help Canada bolster its position as a world leader in space robotics. So I'm here at Queen's to switch gears a little bit from what I was up to in the commercial sector and really get into the nitty-gritty research of autonomous robots for the exploration of the moon or for Mars. I'm also really interested in doing my PhD because it's a really good opportunity for myself to develop as a leader, as a mentor, and as an educator. I first heard about the Vanier Scholarship when I was applying for my PhD. When I heard the results, I was pretty stunned, had read it a few times. I immediately shared that with my wife and my parents.
So Thomas and I connected at a Tim Hortons. Not too long after that, Thomas decided that he would join us here at Ingenuity Labs at Queen's. I knew Thomas was a special guy from that original meeting at Tim Hortons. He's also got a really great mixed background. It's a good theoretical or technical foundation, but also comes along with some maturity in terms of his experience in industry. Even in his short time with us, has reminded me that to be a good researcher, you need to also be patient.
I was lucky though that I found Dr. Marshall because he also has experience in robotics in natural terrain. So with Josh, I'm able to get that technical supervision, which is really important to the success of my PhD. And I'm hoping that I can connect current researchers as well as graduating researchers with the burgeoning Canadian space robotics field. My favorite thing about being part of the Queen's community is getting to be involved with some of the undergraduate teams here. Kingston is a wonderful and beautiful city. It's located on the traditional lands of the Anishinaabe and the Haudenosaunee, and it is truly an honor to get to live and learn here in this wonderful space.
So my name is Michael Fader. I'm from Peterborough, Ontario, and I'm a graduate master's student at Queen's University. My research is in autonomous path following, so using autonomous ground vehicles to drive themselves autonomously outside. So in our case, we're looking into path following control algorithms that are computationally efficient. For the sake of, I guess, more realism, it's better to take it outside. Take a vehicle into some sand, or in our case, we're taking a sandbox here on campus, as well as we're going to drive it in some grass. Just to see what happens in a real-world case rather than an ideal lab environment. Oh, it's been great. Robotics is so interesting, but it's been great having the opportunity to show up to an environment with so many people who are like a wealth of knowledge. Josh and a lot of the other students here, as well as having access to real hardware. It's been perfect, really.